Hello viewers, I'm Kausalya. Today's topic is delta star transformation and star delta transformation. We will start up with delta star transformation. So there arises a question, what is the need of this type of transformation? Right. I'll give an introduction about it. So here you see, look at this circuit. Find the total resistance between A and B. So now just tell me how you will find the total resistance between these two terminals here. So totally here we are having 4 resistors, right? So in among these 4 resistors, you see these two are in series, these two are in series, and again that combination comes in parallel, right? So finding the total resistance is quite easier, right? So these two are in series. Therefore, the resistance in this path is R3 plus R4 and resistance in this path is R1 plus R2, right? So the total resistance is again this combination of resistance and this combination of resistance are in parallel. So we can use the formula R1 into R2 divided by R1 plus R2, right? So now consider this circuit here, right? So here we are having an resistance R5, right? Again it is between the terminals C and D. Now is it easier to calculate the equivalent resistance between A and B terminals? Obviously no, because the circuit now looks bit complicated, right? So here you see, consider this part, right? Now this closed part is known as delta. Now we are going to convert this delta into star. So what is the necessity why we are converting this as star? Because this makes our calculation easier. You see, once this star network gets modified as delta, here you see, now to find the equivalent resistance is easier, right? Again you see, these two resistance are in series, these two resistance are in series, and again and this combination and this combination are parallel to each other, and finally that combination is in series with this resistor RA, right? So in order to calculate the equivalent resistance between the terminals, we are using star delta conversion as well as delta star conversion. It depends upon the area, right? So now let's see the transformation, how a delta network can be converted into a star and what are all the formulas we have to use. So consider 3 resistors RAB, RBC and RCA forming a delta, right? So delta is a closed path. Let RA, RB and RC be their equivalent star network, right? They are connected to A, B and C's. So here you see, this delta is converted into a star like this. So being delta, it is connected between two terminals, right? So A and B. So the resistance here is RAB. And here it is connected between A and C. Therefore it is RCA, and B and C means RBC, right? Now we are converting this to star. So star network always appear like this, right? So we are naming the terminals as A, B and C and respective resistors as RA, RB and RC, right? So here now we are calculating the equivalent resistance between A and B. Now consider this part, okay? We need to calculate the resistance between A and B. So how to calculate the resistance? You see, obviously these two resistors are in series, right? Series, and that combination is in parallel with RAB. So therefore, you see, here, that is when two resistors are in parallel, the formula is R1 into R2 divided by R1 plus R2. So here this is our R1 and this combination is R2, right? Therefore R1 into R2 divided by the total resistance R1 plus R2. Whereas here the equivalent resistance between A and B, okay? So the resistance between A and B is calculated as RA plus RB, right? Now the equivalent resistance is connected between terminals here A and B and here also between A and B. So both are same. So now we are going to equate. So you see this RA plus RB is equal to this combination, right? So mark this as equation number 1 here. Similarly, write down the equations for RB plus RC and as well as for RC plus RA. Right. So here just again you see once you framed the basic thing, you can extract the remaining things accordingly. You see the denominator has RAB, RBC and RCA. So all the denominator holds the same expression. And here you see we are having RA plus RB. Therefore RAB multiplied by RBC plus RCA. Similarly here RBC. So RCA or AB. And here we are having RCA. So RCA into AB plus BC. Right. So now we had framed the respective expressions here. So here we are subtracting 3 minus 2, that is expression 3 and expression 2. So when you subtract, just substitute the values on the left hand side as well as on the right hand side here. So here you see RC and RC cancels each other and the remaining terms are RA minus RB. And similarly here we are doing a multiplication and the common terms are getting cancelled here. Right. So finally I am ending up with the expression like this. RA minus RB is RAB into RCA minus RBC divided by RAB, BC or CA. Now again we are moving, that is we are adding 1 plus 4, that is expression number 1 is, so this is your expression number 1, right? And this is our expression number 4. So we are adding 1 and 4. So when you add 1 and 4, as usual, you have to add the left hand side terms as well as the right hand side terms. And again when you simplify, finally we are ending up with an expression for RA. Right. So this is the resistor value what we need, right? Because we are converting a delta to star. In star network, we need to calculate the values of RA, RB and RC, right? So finally, this is an expression for RA. From this expression, we are writing the remaining expressions for RB and RC. So here RB is, again you see for RA, RAB into RCA divided by these terms, and here for RB, RBC into RAB divided by the same denominator, and for RC also RCA into RBC divided by this part. Right. Now we have converted delta to star, right? Next we are going to see the other conversion. So here the next conversion is star delta transformation, right? Again we have to consider the equations 1, 2 and 3 from the previous case, right? So here we need to calculate the value of, because we are converting a star to delta, right? So this is our star and we are converting it to delta here. So A, B and C. Similarly here A, B and C. So RAC, RBC and RAB. So we need to calculate RAB, RAC and RBC, right? So the first thing is we are going to multiply this 1 and 2 and next 2 and 3 and then 3 into 1, right? So when you multiply, you see RA into RB, that is left hand side, RA into RB gets multiplied. Next we are going to multiply these two terms. So when you look at these two terms, you see here there is an RAB and here also there is an RAB. Therefore the combination is RAB the whole square into RCA into RBC, right? You see we are having 2 RAB. So here I am writing RAB the whole square and the remaining terms RCA into RBC divided by the denominator terms are same. So when you multiply here it becomes square, right? Similarly, so write down do the multiplication for 2 and 3 and finally you see here I am having this expression, and for 3 and 1 I am having another expression like this, right? The next step is we are going to add these three terms, okay, 4, 5 and 6. So when you add these three terms, again you see RA into RB, RB into RC, RC into RA. is equal to, just we are adding. So when you add these three terms, you see again here there are some common terms. That is, you see when you look at the numerator part, or AB is present, or AB or BC or CA. Similarly, or AB or BC or CA, and here also or AB or BC or CA is present, right? So I am taking that term commonly outside. So when you take here or AB or BC or CA, there is a remaining one term of or AB. Here or BC will be remaining, and here or CA will be remaining, right? So therefore, you see when you take the terms, the remaining terms occupy place like this, right? So here we can cancel these two terms. Here we are having a square term, and here the power is 1. So we are cancelling, and the remaining terms are, you see, we are having an expression like this. So again, you see when you look at this part, right? So this part is nothing but it is our RC, right? We have already obtained this expression. You see, this is our expression for RC, right? So we are replacing these entire terms by RC here. So when you replace, you see, our expression gets modified like this. So we need only RAB. So just move this RC to the left hand side. So finally this is our expression, right? In the same way, we are framing expressions for RBC as well as for RCA, right? So they are quite easy to remember. You see the numerator terms for all the thing holds the same, AB, BC, CA. Here the remaining is, here if you are finding or BC, then in the denominator part it should be having A. You see here C and A are present, therefore the denominator term contains B, right? Like this. So here comes the end of this derivation. If you have any doubt, let me know in the comment section. Thank you.